we will learn about probability. Now, probability is the science of chance or likelihood of happening anything surrounding us. So before diving into the main definition of probability, there are a few terms that we very likely use in the course of probability, or they are integral part of the theory of probability that we will get familiar with. First one is random experiment. Now, a random experiment, we all know what is experiment, right? Where we try something and we found out we get an outcome. Now, an experiment will be called a random experiment if it leads to at least two possible outcomes. So there must be at least two possible outcomes with uncertainty. When starting the experiment, will not be certain about the outcome. Let's say, for example, you are tossing a coin, right? So when you toss a coin, the coin will flip and it will fall either on one side or the other side, right? A coin used to have two sides and we call them as head and tail, right? So a coin has two faces, one is called head, one is called tail. When we flip a coin and it gets down, it will either show one or the other face. It will either show head or tail. So in this experiment, we have at least two outcomes, right? Head and tail. And before tossing the coin, we were uncertain whether it will show head or tail, right? So that kind of experiment is called an random experiment. Now, if you note down all the outcomes of the experiment, the possible outcomes of a random experiment is called a sample point. That means in the experiment of tossing a coin, head will be called a sample point. Similarly, tail will also be called a sample point. Right? Now, if you note down these sample points of an experiment as a set, that means if I write down head, tail, now this will constitute a set, right? And this set will be called a sample space, right? And if you collect some sample points and make another set, that will be called an event, right? An event is a collection of sample points of an experiment, right? That event can be collection of a single sample point also. So in this experiment, if I write down a new set, just writing down head, then this will also be called a event. This is called the event of head, right? So let me give you a more practical example which will clear all four terms that are used, right? So suppose a person goes to COVID-19 test. COVID-19 test, this goes to a testing center, right? And when we go to a testing center, the outcome of our test will lead to two results, right? There will be two possible results. One is either the person will be COVID-19 positive, and in the fortunate case, that person will be COVID-19 negative. So this is a random experiment. That means testing for the presence or absence of COVID-19 will be called a random experiment because it has at least two outcomes, right? Now, this positive and negative are possible outcomes of this experiment. So both of them are called sample points. That means testing COVID-19, the outcomes are positive and negative are both called sample points of that experiment. Now, if I write down positive and negative in a set, that will be called the sample space. And suppose I am interested in negative of this result, right? So I am trying to find out the probability of what is the probability of a person being negative, right? So in that case, I am interested in negative. So I can write down a set with only negative, and this will be called an event. So if you collect, now let me give you another example where suppose the sample space is, let's say, 1 2 3 4 5 and 6. So this is the sample space. That particular experiment has 6 different possible outcomes, right? So this will be called the sample space if I write down all the possible outcomes. And suppose I am interested in finding out, or I am only interested in the even numbers, right? So out of the 6 numbers or 6 possible outcomes, if I create another set of the even numbers which are 2, 4 and 6, so this set will be called the event of even numbers, right? Or if you are interested in odd numbers 1, 3 and 5, so this set or this collection will be called the event of odd numbers, right? So from a larger sample space, that means the set of all possible outcomes, it is possible to create a multiple events, right? So some may be interested in finding out numbers less than 4. So in that case the set will be 1 2 3, so that will be also called an event, and to be specific, that will be called the event of getting something less than 4, right? So these 4 terms are widely used in probability: random experiment, sample point, sample space and event. Now next, there are 3 types of events. So far we have learned what is event. Now there are 3 different types of event. First one is called mutually exclusive, next one is called equally likely, the last one is called independent events, right? So what is mutually exclusive? If 2 events, in this case I am denoting them by A and B, if they are such that if A happens, B cannot happen, and if B happens, A cannot occurs, right? So for example, the person who went for COVID-19 test, the outcomes are positive and negative, right? So if a person is positive in that test, the same person cannot be negative simultaneously, that means on the same day, on the same date, on the same time, right? So there is possibility of happening only one out of them, right? There are 2 possible outcomes and only one can occur. We cannot get both the outcomes simultaneously. In such a case, those events are called mutually exclusive, right? So 2 events A and B are said to be mutually exclusive if they cannot happen simultaneously, right? So the next type of event is equally likely, right? So 2 events A and B are said to be equally likely if both have the same chance of happening, right? So before conducting the test for COVID-19, this patient is equally likely to be positive or negative. We cannot put, or we cannot emphasize, or we cannot give importance to one over the other, right? Unless there is some other information that says that this person is highly probable of getting infected, right? So when you toss a coin or you conduct an examination on a student, let's say, so I am conducting an examination on a particular student. So before checking the answer script, I am not sure whether that student will pass or fail, right? I can't be biased to anyone. Similarly, when you toss a coin before a, let's say, football match or cricket match, both the captains does not know which will come, and it has 50-50 chance, right? The common phrase that we use, that it has 50-50 chance. That 50-50 chance, that means they are equally important or their possibility is equal is called equally likely, right? So two things that I am interested in, if they are equally possible, then I will call the events equally likely. The next one is independent event, right? Now, two events A and B are said to be independent if A occurs, it does not impact the occurrence of or non-occurrence of B, right? Let's say today it is raining and tomorrow it is a sunny day, right? So the rain or not raining today has no relation. If it does not have any relation with the sunny day tomorrow, then today's weather and tomorrow's weather, these two events has no correlation or has no relationship between them. In such a case, these two events will be called independent, right? So your appearing for an examination today has no link to appearing an examination 1 week later. Then these two events will be called independent. However, there are certain situations when one event impacts the happening of the other, right? Let's say, for example, the appearance or the successful completion of a task is dependent on a prior task. Let's say you cannot appear for HS examination until and unless you passed HSLC, right? So HSLC is an event and HS final examination is an event, right? We cannot say that these two events are independent because a person cannot appear for HS examination until and unless he or she passes HSLC examination. So HS examination is dependent on the result of HSLC, right? So this type of events are called dependent event. And let's say the marks in English and your marks in mathematics, right? Let's say it does not impact anything on your marks on mathematics. The marks of English does not impact mathematics. So the event of marks in English and event of marks in mathematics will be called independent. Now these are not very appropriate example of an event in the ecosystem of probability, but just remember that if two events does not impact each other, those two will be called independent, right? Now let us define what is probability, right? So the simple definition of probability is, if a random experiment there are n mutually exclusive. Now what is mutually exclusive? That means out of this n, if one happens, the remaining n minus 1 events will not occur, right? One will terminate the occurrence or possibility of the remaining one. So there are n mutually exclusive and equally likely. That means all these n events have the same possibility of happening, right? And out of this, k are favorable for the happening of the event E. So the event, just like my prior example, suppose I am interested in odd, so even numbers 2, 4, 6, right? So this said my event is even number, right? So the set for even number was 2, 4, 6. So this is a sample point, this is a sample point, this is a sample point, right? And these are outcomes basically. So for this event of even numbers, I have 3 different outcomes that support this, right? 2, 4 and 6 support that they are even numbers. So in this experiment, we are making a generic statement. So we have n possible outcomes, out of which, so in that example, we have 1, 2, 3, 4, 5 and 6 possible outcomes of them, and 3 out of them are favorable for event numbers. So we are generalizing it. That means n mutually exclusive and equally likely outcomes, and out of them k are favorable for the event E, right? Then the probability of E is given by favorable number of events divided by total number of events, right? So for example, in this case, if I am trying to find out probability getting an even number, right? Now how many cases supporting it? 2, 4, 3, 6, that means 3 cases. And how many possible outcomes? 1 to 6, that means 6, right? So this will give you the probability 3 by 6, which is half, which can also be expressed as 0.5, right? So probability can either be expressed in terms of fractions, or you can express them in terms of decimals also. So this is the definition, or this is a formula, you can say the formula to calculate probability. It's very simple: favorable number of cases divided by total number of cases or sample points or events, right? So this formula you have to memorize, and it's easy to memorize. You can simply write favorable number of cases divided by total number of cases. Now there are certain properties of this probability. The entire concept of probability has certain properties, and the first one in bold letter is the most important property that you should always remember. Now what are the properties? First property is, which I have already stated that this is the most important, which says that probability of event, that means in simple word, probability always lies between 0 and 1. So if probability is P, it will always be within this range 0 and 1. It cannot go beyond 0 or beyond 1, right? So the least value probability can take, the minimum value probability, the minimum possible value for probability is 0, and the maximum possible value for probability, that means the result of this formula, will be 1, right? Now what is the 0 and 1 means? So if for any event, now E is a very generic term, we are just denoting an event by the word capital E. So E can be anything. E can be getting a positive result in corona test, or negative result in this test, or passing an examination, failing an examination, getting marks more than 30, less than 30, etc., etc. So this, you have endless possibility here. Now if for a particular event the probability is 0, that means that event is called impossible event. That means it cannot occur, right? Impossible event. Now impossible event, though we are using the phrase impossible event, in real life it does not mean it will not occur, it cannot occur, but the data you have with you suggests that it is impossible. But if there are data which suggests that it is occurring somewhere, that means it is beyond your study, right? Now let's ignore that. In simple word, if you find out probability equal to 0, that means that event will be called impossible event. If probability is exactly equal to 1, then the event will be called a certain event. So there are two terms associated with the value of probability. If it is equal to 0, then it is impossible, right? And if it is equal to 1, exactly equal to 1, then it is called certain, right? Now what is certain event? That means it is a constant thing, just like sun rises in the east, right? So sun rises in the east, it is happening constantly and it is not fluctuating. So that is a certain event, and the probability of that will be 1, right? Now in case you want to know what is the probability of not happening something, So probability of not happening A is equal to 1 minus probability of happening of A. Now not happening of A is generally denoted by this. So if you write a bar in top of anything, so there is an event called E. If I draw a bar, that denotes not happening of that event or complementary, right? So probability of not happening of the event E is equal to 1 minus probability of happening of the event, right? So let's say, for example, the probability of sun rising in the east is 1, right? So if I want to find out what is the probability that sun will not rise in the east, right? Probability sun not rise in east will be 1 minus probability sun rises in the east, right? So of course we know probability of sun rises in the east is 1, so this will be 1 minus 1 is 0, and we also know the sun not rising in the east is an impossible event, so that has a probability of 0. So these are some properties of probability. There are some more properties, but these are the most important properties of probability, and you must know this. And the first one is the most important one, because while calculating probability there will be numericals, right? Obviously we will apply the concept or the formula of probability to find out the probability of different events surrounding us. Now in that case, if your calculation gives you value outside this range, if you get something like minus 0.5 or 1.2, right, this will indicate that there must be some kind of mistake in your calculation. You are doing some kind of mistake in your calculation, so that you are getting something absurd. So any value outside this range of 0 and 1 will be a mistake, right? That's an error in your end in calculating probability. Next, we have certain algebra of probability, the different events, the combination of different events, and how they are used in the theory or in the solution of problems related to probability. But before discussing them, we should be familiar with the term union and intersection, right? So union denotes or, right, and intersection denotes and, right? So union is also written as or, and intersection is also written as and, right? So for example, if I write A union B, this means that I am talking about the event A or the event B. If any one of them happens, then it satisfies A union B. But when I write A intersection B, it means A and B, right? Both the events A and B should happen so that A intersection B is satisfied. So if I write probability of A intersection B, the meaning of this is that probability of A happens and B happens, right? Both should happen simultaneously. That is probability of A intersection B. But if I write probability of A union B, this means probability of A happens or B happens, right? Or both of them happens, right? A union B means if A happens, then also it is satisfied. If B happens, then also it is satisfied, right? So there are some algebra that are used in case of probability, which are: number 1, probability of happening of either the events A or B is given by probability of A union B. The probability of simultaneously happening of the events A and B is given by A intersection B, right? and then probability of A union B is equal to probability of B union A. It does not matter whether you write A first then B or B first then A. Their position does not matter. This is true for intersection also, right? Next one is, if you write A union and B union C, now according to the rule of mathematics or the hierarchy of parentheses, anything that comes within a parenthesis is operated first or is calculated first. But this is distributive, right? That means if you find out, now the natural order of calculating this will be, first you will find out the probability of B union C, then you will find out the result and the union with A, right? Now that will give you the exactly same result if you do the steps like this. That means you first find out the A union B, then you union that with C, right? So that means the bracket can be exchanged. Similarly, you can do that for intersection also. And if you have combination of intersection and union, that means A intersection B union C, this will give you A intersection B union A intersection C, right? And the reverse is also true. If I change intersection by union and union by intersection, I will get the same result, right? That means intersection will be replaced by union, union will be replaced by intersection. So these are some algebra that we use in case of probability. And the next one is, now this probability of A intersection B, what does this denote? This denotes, suppose you want to find out the probability of happening of A and not happening of B. That means A happens and B does not happens, right? So B does not happens is denoted by B bar, A happens is denoted by A. Intersection means both the event should happen simultaneously, right? So this is given by the probability of A minus the probability of happening of both the events simultaneously. That means A and B simultaneously happens, right? So if you have the reverse, that means probability of A intersection B, A bar intersection B, suppose not happening of A and happening of B. Now in that case you will write probability of the happening event, right? B is happening minus probability of A intersection B. Now in this case B is not happening, so that's why we are writing probability of A. In this case A is not happening, that's why we are writing probability of B, right? Now this formula, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B is called, this is known as addition law of probability. So this is known as addition law of probability, and this is very important. We will be solving some number problems, numericals, based on this relationship. So what does it state? That the probability of happening of either A or B is equal to probability of happening of A plus probability of happening of B minus simultaneous happening of A and B. That means A, probability of happening of A and B. A or B, A and B, right? So this is the relationship, and this relationship is called the addition law of probability, right? Now in case two events, now what is independent events? Independent events or mutually not independent. This should be mutually exclusive. This is mutually exclusive. Now what is mutually exclusive? I said that the definition of mutually exclusive event is that both the events A and B cannot happen simultaneously, right? Now what is A intersection B? The possibility of happening both the events simultaneously. Now if A and B are mutually exclusive, that means these cannot happen, and if something cannot happen, it is impossible, and the probability of impossible event is 0, right? So there is a property, the possibility of an event, if it is impossible event, then it is probability is 0. And next one is what is mutually exclusive? If two events A and B cannot happen simultaneously, right? So if two events A and B cannot happen simultaneously, then their intersection, probability of A intersection B, is equal to 0. Now this is stated here. So if A and B are mutually exclusive, then probability of A intersection B is 0, and in that case this formula over here reduces to, because this part is 0, so it will be only this, right? Probability of A union B is equal to probability of A plus probability of B, right? So these are some properties of probability. Now there are certain examples that are very frequently used in the theory of probability for the ease of understanding, right? So there are three standard examples that we repeatedly use in probability so that the concept of probability can be explained easily. The first one of them, these are standard random experiments, right? So the first one is coin tossing. Now a coin has two faces. This one is called the head, this one is called the tail, right? So here we have two outcomes, right? Tail and head. So if I write down the sample space, now sample space are normally written as capital S. So here the sample space is tail comma head, right? Two outcomes, tail and head. Now if the coin is unbiased, that means if it is a very good fair coin, that means getting tail should be equally possible as getting a head. Now if the two events are equally possible, they are called equally likely, right? These two events are equally likely. And also these two events, when you get a tail, that means if I throw a coin or I toss a coin and it flips and get back to your hand, you will get only one outcome at a time, right? You cannot get head and tail simultaneously. The result will be either tail or head, right? So if only one can happen at a time, that means these two are mutually exclusive, right? So what is mutually exclusive? That means these two outcomes, there is only one possibility at a time, right? Either tail can happen or head can happen. So in a coin tossing experiment, we have two outcomes, one is tail, one is head. The sample space will be this. These are also called the sample points. This is sample space. The two events are equally likely provided the coin is unbiased, and the two events are, or the two outcomes are mutually exclusive. That means one prevents the happening of the other, right? So this coin is the most simplest one out of these three experiments. The next one is rolling a die, right? So a die has 6 faces, we all know. 1, 2, 3, 4, 5 and 6, right? So a die has 6 faces. These are the 6 different faces, right? So these 6 different faces are sample points or their possible outcomes. So in the first example or the first standard experiment, here we have 2 different possible outcomes. In this case, we have 6 different possible outcomes, right? So these different outcomes are also mutually exclusive. Why mutually exclusive? Because if you throw a die, it rolls and it shows a face. The top face is considered. The top face can only show you one number at a time, right? Whenever we roll a die, it only shows one face at a time. So it can be 1, 2, 3, 4, 5 and 6. So since simultaneously we cannot get more than one, so that's why the events are or the outcomes are mutually exclusive. Now if the die is very uniform, then all of them are equally likely also. That means they have the same amount of possibility. Now in statistics, we consider them to be equally likely unless stated otherwise, right? So this is rolling a die. We have 6 different phases. And the third example is playing cards. Now playing cards are used to explain complex problems of probability. Now why we use the example of playing cards? Because it gives you opportunity of making different combinations. Now a playing cards contains 52 cards in a playing card. Now the entire combination is called a deck, right? Or a packet. The packet is called a deck. So in a deck there are 52 cards where 26 are red and 26 are black. These are black and these are your red cards, right? Now there are different symbols, right? This symbol, this symbol, this symbol and this symbol. We have 4 different symbols. So there are 4 different symbols. Each symbol is called a suite. So there are some terms that you should be familiar with. One is there are 2 colors. One is red color and one is black color. Now there are 4 different symbols and each symbol is called a suite, right? And in each suite we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. That means each group or each symbol contains 13 cards. So in a suite we will have 13 cards, and in a pack there are 4 suites, right? 4 suites. Each suite has 13 cards, right? So you see in some of the cards we have numbers written 2, 3, 4, 5, 6, 7, 8, 9 and 10. And in some we have some letters written A, J, Q and K, right? And this tree has some photographs or some pictures, right? So these are there. So in every suite there are 2 different types of cards, right? So I have written here. So this symbol is called a club, right? The symbol like this is called club. Now let me draw appropriately because it is black. So symbol like this is called a club. A symbol like this, an inverted leaf kind of symbol, is called spade. This is spade, this is club, right? Now if the symbol like this is called diamond, and symbol like this is called, we all know, heart, right? So this is the suite of, this is club, this is spade, this one is heart, and this one is diamond, right? So we have 4 different suites, 26 red, 26 black. Now in each suite there are some cards with numbers. So these 2 to 10, these are called number cards. These are called number cards. And this A and this J, Q, K are called face cards, right? So in every switch there are 4 face cards and 9 number cards, right? And this card J over here is called Jacob, this Q over here is called Queen, and this K over here is called King, right? And this face card where we have only one letter called A is called Ace, right? So 2 to 10 number cards. Then we have 4 different face cards. One is called Ace, one is called Jacob, one is called Queen, and one is called King, right? So 4 different suites: club, diamond, heart, and spade. 13 different cards, 2 up to 10 number cards, and then Jacob, Queen, King, and Ace, right? 2 to 10 are called number cards. Jacob, King, Queen, and Ace are called face cards, right? So in every pack of cards where it contains 52 cards, there will be 36 number cards and 16 face cards. Now this might be very intimidating at first, but if you look closely or if you do few numericals based on this, you will be comfortable in the problem related to playing cards, right? Now let's do some examples. The first example is 3 coins are tossed together, right? So we are tossing 3 coins simultaneously and we are trying to find out the probability of getting at least one head. Right? So in any example related to probability, when you are solving any problem related to probability, the first thing is to write down the sample space. The first step is always to write down the sample space. Now this is only recommended in case of if the example is related to coin or die, or let's say something which has less number of possible cases, right? But in case of cards, playing cards, the possibility is 52, right? So it is not possible for us to write down the sample space. So if your sample space contains a large amount of information, that means large number of values, we can ignore creating the sample space. But for small number of possible cases, like for in case of coins, we have 2 possible cases. In case of throwing 3 coins together, we will have a different number of possibilities. But it is suggested that you create or you write down the sample space. So let's try to write down the sample space. So I will write down the solution here only. Solution. Here the sample space is. Now sample space is denoted by capital S is equal to, we will write down a set. So we are throwing 3 coins, right? And every coin can result in either head or tail. We will denote head by th and tail by t. So what are the different possibilities that can happen? I can get all the coins showing head, right? All 3 coins may show head, right? Then the first 2 coins may show head, and then the third one is tail, or the second one shows tail, or the first one shows tail. Now remember, though there are 2 head and tail, the position matters here, because the position says which coin is showing which face, right? The next possibility may be 1 head and next 2 are tail, right? Next may be tail, head and tail, or tail, tail and head. The last one is tail, tail and tail. That means all of them are tail. Now how I know that this one is the last one? I don't have any more possibility. For that, there is a formula, right? The formula is n by m to the power m, right? What is n? N is the number of possibility and m is number of repetition. Now in our case we are dealing with coin, right? So a coin has 2 possibilities. That means in our case n will be equal to 2. Now what is repetition? We are dealing with 3 coins. So in our case m will be 3. So 2 to the power 3, 2 cube is 8, right? That's why we are getting 1, 2, 3, 4, 5, 6, 7 and 8 number of different possibilities, right? So in this case, in this example, the sample space is either you can get all 3 heads, the first 2 head, third one is tail, first head, then tail, then head, tail, head, 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 tail, 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 head, tail, 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 head and tail, tail, tail. This is the cases, right? The sample space. Now we are interested in finding out the probability of getting, emphasize on this word, getting at least 1 head, at least 1, right? So once you write down the sample space, next thing is to write down the set of favorable cases. So you write down favorable cases is equal to, now what are the favorable cases? We need at least 1 head. Now when you get 3 heads, we are obviously getting at least 1 head, right? So that means this is favorable for us. That means we are interested in this. The next one is also we are getting at least 1 head, right? The next one is also we are getting at least 1 head. The next one also satisfies. The next one also satisfies. Okay? The next one is tail, head, tail and tail, tail, head. The only possibility that does not satisfy our condition of getting at least 1 head is the last one, where we are not getting any head, right? We are not getting at least 1 head. So these are our favorable cases. So from the sample space we have extracted what are favorable for my question. So all these 7 things, 7 possibilities are favorable for getting at least 1 head. So the size of sample space is 8, right? There are 8 outcomes or 8 possibilities. The size of my favorable cases is 7. There are 7 possibilities. So therefore, probability of getting at least 1 head is equal to how many favorable cases? 7. How many total number of cases? 8, right? So this is the probability that we need, right? The required probability. So this is how we calculate probability. First, you create a sample space if it is not big enough. Next, you find out those cases which are favorable for your question, make a set for them, count the numbers in both the set and put them in the formula, which is probability equal to favorable cases divided by total number of cases, right? Now the next example is about dice, and here we have two dice which are rolled together, and we are interested in getting some same value on both the dice, right? That means getting 1 on both of them, 2 on both of them, etc, etc. So to solve this, just like the previous example, we will first have to write down the sample space. Now here we are rolling 2 dice, right? And every dice has 6 possibilities. So in this example, our n is 6 and we are rolling 2 dice, so m is equal to 2. Now the formula was n to the power m to find out the total number of possibilities. So here it will be 6 squared, that means we will have 36 different possibilities, right? So that means our sample space will contain 36 items. So I will first write down the sample space. Now the solution is in the format. First of all, you will have to write down the sample spaces. Now I'm writing it in the top. The sample space is denoted by S is equal to, that will be a set. Now the set will be, the different possibilities are, let's say in your first die you got 1 and the second die you got 1 again, right? So the possibilities is 1, 1. That is one possibility because we are rolling 2 die. Now the next possibility is, we will keep this 1 constant and we will change the result of the second die, right? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6. So these are the 6 possibilities, keeping the result of the first die constant. Next we will write down 2, 1, 2, 2, 2, 3, 2, 4, 2, 5 and 2, 6. Now these are the 6 possibilities when the result on the first die is fixed as 2, right? We can write down again 3, 1, 4, 3, 2, 3, 3, 3, 4, 3, 5 and 3, 6. Next we will keep 4 constant, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5 and 4, 6. Next 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. And the last line will be 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. Now the question may arise that what is the difference between 2, 1 and 1, 2? In this case, the 1, 2 and 2, 2 are treated differently because they represent results of different phases in different dice, right? So 2 is occurring in the first die. In 1, 2, 2 is occurring in the first die, and 1 is occurring in the second die, right? So the position matters. Now if you count here, the value or the total number of possibilities we got along here 1 2 3 4 5 6, along here 1 2 3 4 5 6. So we have 6 into 6, 36 outcomes, right? And the formula also suggests that we will have 36 total possibilities. So this is our sample space. Now the question is asking the probability of getting same value on both the die. That means both dice are showing the same number. Now what are the favorable cases, right? Favorable cases. So I will create another set for favorable cases. And what are the favorable cases? 1, 1 is one of them, right? Because it is showing same number on both the die. 2, 2 is another favorable case. 3, 3, 4, 4, 5, 5, and 6, 6. So both die, that means if this is your first die, second die, they are showing the same number 1, 1 or 2, 2 or 3, 3, etc. So there are 6 such kind of events, right? So the combination of those 6 events is our favorable cases. So what is the size of our favorable cases? We have 6 such favorable cases, right? And what is the size of our sample size? That is 36. Therefore, required probability is equal to 6 divided by 36. So we have six such combinations which support the statement that we are trying to find out probability or the event that is getting same value on both sides, right? And there are 36 total number of cases. So this is 1 by 6, right? So this is the required probability. So the probability of getting same numbers if you roll 2 dice together is 1 upon 6, right? So the next example is related to a pack of cards, right? And we have drawn one single card from a pack of cards, and we want to find out the probability that it is a king, it is a red card, it is a face card, and it is a number card, right? So we have 4 questions of the same situation that we have drawn a single card from a pack of card, right? So in a pack of card we have 52 cards and we are drawing a single card, right? So in this situation, in case of cards, we normally don't write down the sample space because it is not possible. Rather we directly write down the answer, right? Now later on in our next lecture or in our future examples, we will learn about how to apply combination. That means the formula NCX. We will learn to apply the concept of combination while solving problems related to cards and some other problems also. But for this example, it is a very simple example. You are drawing a single card from a deck of cards. So you need probability under different situations. The solution of the first one is it requires a king, right? So we know the total number of cases in this case is 52, right? So that if you write down the sample space, it will be something like 2, 3, 4, 5, right? J, Q, K, A of blacks, of diamonds, and spade, heart, everything. So you have 52 such numbers. That will be our sample space. Now what is the favorable cases if you want king? So there are 4 different kinds of cards, right? King, containing king. So we have 4 cards which contains king. One is of diamond, one is of heart, one is of spade, and one is of club. heart, diamond, spade and club, right? Sorry, club and spade. So we have 4 different king cards, right? So number of favorable cases is 4 and total number of cases that will be 52. So the required probability will be probability of king is equal to 4 by 52, right? The next question is number 2. It is a red card. So this is our diagram for cards, and here you can see that in case of red cards we have 13 red cards of heart, 13 red cards of diamonds, right? So if you are drawing one card out of these 52 cards, the total number of cases will be 52, and favorable cases, that means how likely you are getting a red card, there are 26 such favorable cases. So what will be the probability? In this case, for number 2, the probability will be probability red cards is equal to 26 divided by 52, right? Because there are 26 red cards and total number of cards is 52. Number 3 is, it is a face card. Now I have already shown here that in a pack of cards there are 16 face cards, because 4 cards for each suite, 4 suites, so 4 into 4 go to 16 face cards. So these are 12 and these 4, right? So 16 face cards. So what will be the probability? Probability of face cards is equal to 16 by 52, because there are 16 face cards and total number of cards is 52. And last one is just a number card. So how many number cards in a pack? There are 9 cards in every suite and there are 4 suites. So 9 into 4 equal to 36 number cards, right? So here probability of number cards is equal to 36 by 52, right? So this is the required probability of getting a number card when you draw a card from a pack of 52 cards, and 16 by 52 is the probability of getting a face card. 26 by 52 is the probability of getting a red card, which is equal to 1 by 2. And the first one is 4 by 52 is the probability of getting a king if you draw a card randomly from a pack of cards, right? So this is how we solve questions related to coins, dice and cards, right? So that's all for this one. In the next one we will solve some more questions related to probability, and we will also use the concept of NCX, and we will also learn a new kind of probability which is called conditional probability, which is very essential in real life examples or in real life situations, right? So that's all for this one. See you in the next one.